let's take a look. Here, I'm simplifying. Okay, now I notice right away that the square root of 50 is not a whole number. There's no number that multiplies by itself to equal 50. So I'm going to go ahead and factor. This is 5 times 10. 5 is prime. 5 is prime again, and 2 is prime. So now I'm going to do the same thing that I was doing when I was simplifying with only a number. But this time, I'm also going to include my variables. This is 4 a's and 3 b's. And I'm going to do the same thing, right? Which is I'm going to say, oh, this is a double. This is a single. This is a double. This is a double. This is a double. This is a single. Notice this is going to end up being really easy because my work is neat. Okay, if your work is crazy and messy, that's going to lead to mistakes. Now, I'm going to write the long way. If you want to just skip writing this next step, you can. Okay, but what I'm going to do is I'm going to show you, oh, look, this double goes in its own house. 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 And the singles, the 2 and the b, that goes in its own house. Okay, now you don't have to write this. Why? Because look, this double, this becomes 5 times 5, and the square root of 25 is 5, right? The other way to think about this is that this is 5 squared and square rooted. So squared and square root, those are inverses, they undo each other. I'm just left with 5. This is a squared and square rooted. That just undoes it. So I'm just have a, right? This is the same as the square root of a squared. So this and this cancel out, I'm left with a. And here I'm left with another a, so that's a times a, and a b. And then this is where there's not that double, so this is not anything squared. So when I square root it, it doesn't simplify, and it just looks like this. Okay. Now, you don't have to write this step, because what? Why? Because look, I can just say, oh, this double 5 becomes a 5. This double a becomes an a. This double a becomes another a. This double b becomes a b, and the singles are left inside the house. So this is why this works, but you don't have to write it. Okay, let's take a look at another problem. Let's simplify again. This time, I'm not simplifying with a square root sign. Okay, notice that this problem looks similar to the last one we did, except for this negative exponent. So let's talk about what that negative exponent means. Remember that negative exponent means that it's in the wrong spot. It's unhappy here. It's on the wrong side of the fraction. And you might ask yourself, well, what fraction? Well, you can view everything as a fraction, right? You can say, oh, look, this is 5n to the negative second p to the fourth over 1. And you say, this negative exponent, that means that n to the negative second is not happy there. The n to the negative second will be happy, will be positive down here. Up top, it's negative. So I'm going to rewrite, look, I'm going to give myself space to write a fraction. Notice I'm not trying to squeeze it on one line because that leads to mistakes. I'm writing it so I can write it big and neat. I'm bringing this, right? It's still going to be cubed. I'm just going to rewrite this. And what am I rewriting? Only the n. The 5 is perfectly happy up here. The p to the fourth is happy up here. The n is like, oh, I'm negative up here. I don't like it. Okay, cool. Oh, now I'm happy down here. Okay, so notice the 2 is not negative anymore. This little straight mark looks like a negative. The 2 is not negative anymore. It's here. It's down on the bottom. Okay, now I still need to take it to the third power. So once again, for me, I don't like using the rules. I just like writing out what this means so I can just see what it means and do the math that way. Okay, so this means this whole thing to the third power. Okay, so that's what this means. I'm writing it out the long way. A shortcut I like to use is to just write it out once and then just make the parentheses and pretend it's written out 3 times in my head. That saves a little bit of time. You can do that. But let's go ahead. We're going to multiply across the top first. So 5 times 5 is 25. 25 times 5, that's how much do I have if I have 3/4? I have $1.25. This is p times p times p times p times p times p. How many p's? Well, I have 4 p's. 4 more p's, that's 8. 4 more p's, that's 12. Now, when I multiply fractions, I multiply across the top, and I multiply across the bottom. So this is how many n's? This is 2 n's, 4 n's, 6 n's. That's that. All right. Last example problem. I'm going to solve Okay, how do I solve this problem? Notice, this problem doesn't have a squared in it, it has a square root in it, right? So how do I solve it? Well, I always solve using inverse operations, always, always. So if I see a square root, I say, what's the opposite of square root? Oh, the opposite of square root is squared. So what am I going to do? I see the square root, okay? The square root is in the problem. What am I going to do? I'm going to square it. And if I square on the left side, then I have to square on the right side, okay? So I'm going to square this side. Why am I squaring it? Because I see the square root. The square root and the square cancel. So when I bring this down, I just have 3x minus 5 left. Why? Because I've squared and square root cancel each other out. Over here, I need to do the math. 7 squared means 7 times 7, and that's 49. And now, this, I'm just going to solve it like it's week 2 of school. Okay, now notice, I don't have two answers here. Why? Because 7 times 7 is just 49. There's no, oh, it could be negative 49. No, it can't. It can only be this one thing, positive 49. So I'm going to go ahead and solve. Okay, 54 divided by 3 is 18, and I'm done. Look, you can plug it back in to check if you want. 3 times 18 is 54, minus 5 is 49, and then the square root of 49 is 7. Yep, that works. Looks good.